Assalamualaikum and hi. My name is Khadijah Saidi. My number metric is 824KE0317.
Hi, I am Natasha Amira binti Muhammad Subilan. My metric number is 824KE0242.
Hi, my name is Alicia Nita and my metric number is 824KE0046.
In this video, we will explain about matrix algebra. Assalamualaikum and hi. Today I will show you how to do inverse matrix by using adjoint method. So, this is the question for solving the inverse matrix by using adjoint method. Okay. So as you can see here, this is the question. This is our question, and I come out the number of every days into this form. Okay, so in the matrix form, I get 2, 3, 1, 2, negative 2, negative 3, 3, negative 5, 2, bracket x1, x2, x3 equal to 11, 5, negative 3. This is our matrix A, this is our X, and this is our B. So, to find inverse matrix by using adjoint method, this is the formula for to find it. Okay, this is formula. First, we need to get the determinant. Okay, and then we have to get the adjoint A. So, to get the determinant first, of course we need to find the determinant. So in this case, I pick row 1 to find the determinant of A. So like usually you have to find it, so you will get negative 81. Okay, negative 81 is not equal to 0, so the inverse is exists. If not, if the answer is 0, so the inverse does not exist. Okay, so after that we need to find the cofactor of every number on this matrix A. Okay, so I will show you just one example. C11 is referring to C of cofactor of row 1 column 1. So you just need to cover this and you will get this number. So just find the cofactor and you will get the answer. You need to do the same thing on every number of determinant A. Okay, after you get all the cofactor, you need to write in this form. Okay, so now we only just get the cofactor. After that, we need to get the adjoint A. Adjoint A is referring to the transpose of cofactor. So we already get the cofactor. You just need to transpose it. We get this adjoint A. Okay. So you already get the determinant and you already get the adjoint A. After that, we just need to put it on our formula, which is this formula. Okay, 1 over negative 81 multiply with our adjoint A. Okay, after that we get this answer, and lastly you need to write in this form to get the value of X. Okay, X is actually A inverse of B. So we already get our A inverse, and B is our question, right? So you just need to multiply one by one like this. I'll show you. Okay, this you need to multiply with this, and then plus with this, multiply with this, plus with this, multiply with this. Okay, and then you will get the value of 3. Same goes to the others. You need Okay, plus with this and this. Okay. Okay. After that, we get the answer of 2 and also 1. Okay, so finally you get the answer for our x, which is x1 is equal to 3, x2 is equal to 2, and x3 is equal to 1.
Okay, next I will continue with these questions. So given that P equals to this and Q equals to this, calculate PQ, hence deduce the inverse matrix of P. So the first step is we will multiply the P and Q. Okay, the step of multiply is to get the first row. We will multiply the first with the first row with the first column. Next, second row with the first column, and continue with third row with the first column. So the same as the second column and the third column. This one. Right. So we'll get the answers like this. And since we can factorize, so we can bring out the 21 and we'll get the identities here. So we can replace the matrix form with I. So we'll get PQ equals to 21I, and the question says that deduce the inverse matrix of P. So we'll multiply the PQ with the P inverse for both sides, and so we can cancel this out, and so we get Q equals to 21I P inverse. So we can get P inverse equals to 1 over 21Q. So 1 over 21Q. Calculate the numbers, so we'll get the answer like this.
Hi, I am Natasha. So I will continue with the last question. The question is, solve the following system of linear equation by using Gauss elimination method and Gauss-Jordan elimination method. So here the equation that given to me. I transfer this equation into the matrix form like this. So let's start with the Gauss elimination method first. First, you need to write this matrix first, and we need to check either this row have leading one or not. So this already leading one, so we don't need to change anything. So we will move on to this number, which is -1. So we need to change this -1 into 0 by using this equation R1 plus R2. So we got this, and this number below already 0, so we don't need to change anything. So let's move on to this number, which is 2. We need to change this 2 into the leading one by using this equation -R3 plus R2. So we got this, and lastly we need to change this one into 0 by using equation -R2 plus R3. So we got this matrix form, which is REM. So we need to transfer this matrix into the equation form like this, which is x1 plus x2 plus x3 equal to -2, x2 equal to -1, x3 equal to 0. We need to do a little bit of calculation for this. which is we need to substitute the value of x3 and x2 into this equation. So we need to solve it first, and we got the x1 equal to -1. So here the answer, which is x1 equal to -1, x2 equal to -1, and x3 equal to 0. So let's continue to the Gauss-Jordan elimination method. So I take the previous metric form, this, to continue to do Gauss-Jordan elimination method. So since this number already leading 1, so we need to change this number and this number into 0. So firstly I change this number first by using negative R2 plus R1, and I got this. And lastly, I change this one into 0 by using equation negative R3 plus R1. So here we got this metric form, which is RREM. For RREM, we can directly take this value as the answer. So here the answer for x1 equal to -1, x2 equal to -1, and x3 equal to 0. So this answer is same like Gauss elimination method. So that's all from me. Thank you.